In this lecture, you'll learn about the benefits that network programmability and automation provides over traditional network management. Looking at traditional network management first, the way that that is done is by configuring your network devices, your routers, your switches, firewalls, etc., one at a time using SSH to the command line. So if you're the network administrator, and you have to configure 5 routers and 5 switches right now, what you'll do is you will connect to them separately and you will configure them each individually, one at a time. And copying and pasting a config from a text file is the usual way of doing things. As well as the command line, GUI tools have also been available for a long time that let you work on routers and switches and firewalls one at a time, but they're typically very slow to use, which makes them inefficient. So network administrators will usually use the command line. There are also NMS, network management systems, such as SolarWinds and Cisco Works that used to be available quite a long time ago, and Cisco Prime Infrastructure. They use protocols such as SNMP and NetFlow to gather information from the network devices and report on the state of the network. SNMP was originally proposed in 1988, so it's been out for a very long time. As well as being able to pull information from network devices, SNMP can also be used to push configuration to them as well, but it's got limited functionality there. So it's used more commonly for pulling information and reporting rather than for pushing configuration. Those solutions can be complex to implement and operate, and SNMP also has some security concerns as well. So looking at the issues with traditional network management, configuring one device at a time is time-consuming and inefficient. Obviously, if you have got 30 devices that you need to configure a day, it's going to be a lot quicker if you can push the configuration to them all in one go, rather than logging in and configuring each one at a time. By configuring each one at a time, that also increases the likelihood of typos and other mistakes as well. So maybe you do one configuration on device A, you accidentally do a different configuration on device B. Individual edits to multiple devices by different network engineers over time with little version control also leads to configuration drift, where you've got non-standardized configurations. So the first network engineer might configure a particular feature in one way, a different network engineer might configure it in a different way. And having those non-standardized configurations and accessing one device at a time is also inefficient for troubleshooting. So let's look at network automation now and the benefits that it can bring. Automation can be used for device configuration, pushing your configuration to your devices, also the initial device provisioning when it first comes from the factory. You can use it for software version control to make sure that your devices of the same types are running the same software version on there. You can use it to collect statistics from devices and report on those. You can also use it for compliance verification. So you can take your known good configuration that the device should have and use automation to check that that is what is actually configured on the device. It can also be used for troubleshooting as well, because automation can provide an organization-wide view of the network, which means that you can do system-wide troubleshooting rather than having to do one device at a time. Network programmability enables the automation, and that reduces human to machine interaction. When you've got a machine that's doing the work, it's going to do exactly what you tell it to do. Machines don't make mistakes. So if there is a mistake, it will be because you have misconfigured the machine. So by having a machine do that work, that greatly reduces the chance of human errors such as typos. Modern programmability and automation tools have been built with monitoring, configuration and troubleshooting in mind. And it's much more scalable when you can use automation to manage multiple devices at the same time rather than doing them one at a time. Network programmability can provide configuration version control. So you can use that to look at the history of what changes have been made. It's also very easy to roll back to a previous version if that is required. And as well as the configuration version control, where you're checking what changes are made to the configuration on device, it can also provide software version control, where you check that the operating system on your different devices is the one that it should be. Troubleshooting is more efficient with a system-wide view. That way you can correlate events between your different devices all in one global view rather than trying to do it the old manual way of one at a time. Events and error codes can be acted on programmatically, so you can automate your response if there is a problem. And improving configuration and troubleshooting efficiency obviously reduces your operational expenses. Automation also provides assurance, which can ensure devices have a standardized configuration. It can also provide reports on and correct any exceptions to that. It provides correlation between events on different devices for that easier troubleshooting, and it can take corrective action on events and error codes. Okay, so that is the benefits that we get from automation. Which automation method should you use? Well, it depends on your particular environment, because there's lots of different ways, lots of different software tools that you can use to implement this, such as Python scripts, netconf, restconf, Ansible, Puppet, SDN, Cisco DNA Center, etc. We're going to be talking about all of those different options. You're going to learn about them all in this section. Now, not all of those methods are supported by all devices. So which one you're going to use depends on what is supported in your environment, what is most suitable for your environment, and also the skills that you have as well. So maybe you'll be able to use Ansible because it's very simple, but you don't have Python skills right now. Well, in that case, Ansible would be a better choice for you. Now, don't worry about all of the different methods you see there, because you are going to learn about them all in this section. Okay, before I wrap up here, I want to show you automation in action so that you can visualize this and get an idea of how useful it is. So it's something you've seen before. It is configuring a virtual machine in Amazon Web Services. So you can see here I've logged into my AWS account, and I want to configure a virtual machine here. So first off, I choose the operating system that I want the virtual machine to be running. So I will select that. Then on the next page, I select how powerful I want this virtual machine to be, how many virtual CPUs it will have, and how much memory. And then I click next on there. And then on this page, you see I've got all the networking details. So I select the network that I want to use here, the subnet, if I want it to have an IP address, etc. Then I configure the storage, the type of storage I want this virtual machine to have, and how much it needs. I can add tags, which makes it easier to manage. And then I configure the security group, where is where I configure the firewall rules. So you see that the way that this works is there's the web-based front end that will then talk to some software behind here, which automatically configures the virtual machine with the settings that I requested here. Now, the old traditional way of doing this, if you wanted a new server, is you would talk to the different IT teams. So you would have to speak to the server team, also the storage team, and the networking team as well. Everything would be done manually. It would maybe take a few weeks to get this server up and running. With automation, the server can be running in 15 minutes. Now, obviously, when we put these settings in, it's not being done manually by people over at AWS. This is all being automated through software. And it would be impossible for AWS to do this manually. Their business model would not work. So you can see when we've got a very large environment, the benefits of automation are very obvious. If you're in a small environment, though, you can still get benefits of automation as well. So if you're just configuring 5 devices, it's still quicker to do 5 at a time than it is at 1 at a time. And also with the troubleshooting, with the system-wide view you can get with network programmability, you're also going to get big benefits there. So network programmability and automation, it's actually a relatively new thing. We've been working on our network devices at the command line for decades. Automation has really just taken off in the last few years. It's been driven, first of all, by large organizations and cloud providers and service providers, but the benefits are going to trickle down to smaller organizations as well as more software tools become available. Now, if you're worried that automation is now going to mean, well, what's the point of being a network engineer now then, if everything can be done automatically, there's not going to be a job for me anymore? Well, with this automation, the people that are going to be configuring this, you still need to understand how networking works. So everything that we've learned earlier in the course about what all the different networking technologies are and how to configure them, you still need to know that information. So you've got that baseline information now. You can now take it and improve on your working practices by using automation. Okay, that's everything I needed to tell you here. See you in the next lecture.